And the only part of astronomy that I understand is Orion's belt, because it's so identifiable. The three stars are just like in one line. So in the spiritual conspiracy theories, I found out that it's something related to the alignment of the pyramids as well.
These stars are projected in the sky. They're not at the same distance.
What?
They're not at the same distance. They can be at different distances. What I have understood with this Orion connection between Orion and the pyramids of Egypt is that the Nile floods in a particular season. So they wanted to figure out when Orion rises in the east. Ooh. That is when the Nile floods. So their calendar, and then the identifying there are some particular holes in that directly. You can see at that position Orion coming up. The black holes are of different types, like, stellar black holes where, this is a serious case where you have a star and a white dwarf. White dwarf is basically the remnant of a star. Black hole is what physics means that the density is so high that the light cannot escape. You cannot see it. So you have to detect it in an indirect fashion. Where the star which is going around the invisible black hole. Yeah. So that is how we estimate that there is a huge mass present in a small volume. That could be a black hole.
It's a conversation with one of the country's leading astrophysicists. This is Dr. Annapurni Subramaniam, who's the director of the Indian Institute of Astrophysics. Asked her everything from details about the center of the Milky Way to details about our own solar system to details about science, even discuss time travel and interstellar. But if you're someone who enjoys our astrophysics conversations, you're going to have a ball listening to this one. I had a blast recording it for you guys. Enjoy the science special of TRS. It's a heavy episode, but it's an episode that will stay with you for a very long time. Dr. Annapurni Subramaniam, I'm so honored to be hosting you on TRS. How are you, ma'am?
I'm good, and thank you so much for inviting me on the show.
It's genuinely our honor. I didn't even know that there's an Indian Institute of Astrophysics until fairly recently. And with everything that's happened with Chandrayaan 3 and this general revolution of science that we're seeing in India, I've decided that now it's time for all the great scientists of our country to be on TRS.
Amazing. Yeah. Looking forward to listening to more scientists on TRS.
Okay. Is it true that many scientists take up the job profile of being a scientist because of their love for science fiction? I've seen this a lot. So was that true for you as well?
Not really, but they do take up the job because, or rather that particular route because they're passionate about it. So how they got into it could be of different reasons, but of course, science fiction is definitely a reason. Yes.
Okay. Why don't we explain what astrophysics is? What is astrophysics?
Okay, so astrophysics is astro and physics together. So it's a combination of astronomy and physics, let me put it that way. So astronomy is an ancient science where you actually look at the sky and patterns of the sky, including the star, moon, etc. And then physics comes into explaining why are they the way they are. The sun is there. Why is the sun the way it is? How is sun able to shed light and energy for such a long duration and still be the same, right? And why is moon not able to produce its own light? Why is it only reflecting the light? So why are the stars nearby the way they are? How are they? How far are they? So these questions, once you start asking questions in terms of why, then you have to bring in physics and also mathematics.
Why mathematics?
Mathematics, because why are they going in circles and what is the radius of the circle? Is it circle or ellipse? And then the angles, if you want to actually measure the distance between, they are all on a curved, because it's the angle. It's not like they are not traveling in straight lines thing. So you need to look at mathematical solutions to it. So maths and physics come in. So then you are looking at the whys. Why is the way it is? And what is actually happening. And if you know it is, then the astrophysics come in to understand our planet. I mean, planet basically it becomes Earth sciences, and you start looking at planetary sciences. Then it becomes our planets around us and nearby solar system. Astrophysics is generally little beyond that, over the sun and the heliosphere. Heliosphere would mean that the entire sun and the region which has impact from the sun. So it's called heliosphere.
Like up till Pluto.
It could be beyond also. The wind from the sun keeps going. So it can go to very far distances. So heliosphere engrosses everything. And then beyond the nearby stars, and then it becomes the galaxy, and then the far beyond, and the beginning of the universe and cosmology.
My very educated mother just showed us 9 planets. So that's Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune.
Pluto is not a planet anymore. It is actually looking as a dwarf planet.
Okay.
So when I was in school and when I think I was even in PhD time, it was still considered as a planet. No, we don't consider that as a planet. We call it as a dwarf planet. The reason being, it's interesting that in the last 25 years or so, I think, or a little more than that, we now know that other stars have planets. Till then, we knew, we can speculate that, like, sun-like stars might have planets, or there could be solar system outside, but we didn't know. We didn't know in the sense that you can theorize, but you have no evidence. But then the evidence started coming in the last 30 to 25 years. And then we started seeing that at least one planet is around the star. Then now we can say that groups of planets are around stars. So outside solar systems are there. Then if you look at, then you start comparing your solar system with other solar system. So then if you look at it, then it says that all the planets have to be in the similar plane. Pluto is actually slightly out of the plane. Yeah.
But so it's still revolving around our sun, right?
It's there. It's a dwarf planet, that's all. So it's slight difference in nomenclature. When you compare yourself, it's like nearby houses come and you have a house, and then you look at the house and you recalibrate yourself, kind of a thing. Yeah.
It's like there's a stereotype in Mumbai that if you're from Thane, you're not really from Mumbai. Anyway, never mind. I don't believe that. I think Thane people are from Mumbai. My point is, do we know everything about our solar system?
No.
So, someone had actually pitched this on the show. I think it was Abhijit Chawda. He said that there could even be more planets around our sun, which are revolving around our sun, which maybe we've not discovered. Is that true or not?
There is a possibility of another planet, which is actually possible in the sense that there is some. So how do you know how many planets are there? How the heck are you going to say that there is another 1 more or 10 more, or how are you even finding out that, right? So there are orbital calculations you do. Just like the way you orbital calculations for, from here to Mars, if you want to travel, how much force you have to put. So if you put the force, you actually reach there. So that means you have calculated the parameters, which including the distance, the mass, everything is correct. But when you do this orbital dynamics, and you don't have to actually go there, but then predict that orbit is actually closing, there would be errors, or there would be, let's say, when you actually have a model and the observation, you compare it, there will be residual. We call it as a residual.
As in gravitational pull is happening because of something, but you don't know what.
So your theory is not completely correct with the observation. Something is missing.
Okay.
So then that mismatch can be said that maybe because of something which is, we have not accounted for something. Okay. And that is basically possible. Okay.
So you're saying that when you apply mathematics to our solar system, there is a lot of factors that come into play: orbital length, gravitational pull, etc.
Yes.
And when you guys as astrophysicists deep dive into this mathematics, there is some unknown factor which is causing a residual gravitational pull or affecting the other planets.
Yes, the model is not matching with the data. So what basically in astronomy we do is, it's not like in laboratory where you can actually do it and wait and say that and all that, right? So you get the data, and then you have to have a model theory that this is how it is, physics-based theory and mathematics-based theory. This is my model, it has to fit it.
Okay.
So then you actually say that, okay, at this time, the Pluto has to come back to this, for example, has to come back to this exact point with this exact precision. Now, according to your theory, this is what is predicted, but it might not do that. It might give a residual. Close to it, but not exact.
Okay.
Now, that would mean that in your theory, you have not, in your model, you have not accounted for something. Something is missing. But you have to figure out what is that is missing.
There's some mystery in the mathematics of our solar system.
Not mystery in the mathematics, but something which is some component which is not fully accounted for.
Okay.
So that probably can give a residual.
And what are the theories? That there is a black hole, I think.
There is
somewhere.
a small particle which we are not able to detect or not able to properly get its orbit.
Okay.
So there are some, I'm not very well sure about it, what exactly it is, but I'm not able to recall what exactly it is. But there is a mismatch, but then this is very small thing which is we are missing. So we still have to figure that out. Yeah.
Okay. But one of the theories is that it could be another planet.
It could be a small outside one, but we can't say it is a planet or a dwarf planet. Yeah, because Pluto itself is a dwarf planet.
But if we are able to know about all these random planets we find so far away, all these X 1, 2, 3, 4 planets, how do we not know that there could be another planet in our own solar system which is so tightly packed?
Yeah. So how do we find planets? Is one, you have to find the planets are not emitting light. So you have to get the light, reflected light detected. Okay, it's a highly precision-based one.
As in, there's a telescope on Earth which captures the image of the planets?
Yeah, so how do we, the question is, you kind of alluded to, how do we detect planets far away, right?
Yeah.
So it's a highly precision measurement. Let's say, I'll give you a very simple example of it.
Sure.
You say the Earth is going around the sun. But do you say sun is going around the Earth?
No.
Why?
Because my science textbooks taught me the
Okay.
otherwise.
No, if I say yes, it is possible that we can say the sun is going around the Earth. So that is how you start doing science, is you start questioning. Okay, when there are two bodies which are going around each other, the science also tells you that they go around the center of something called mass.
Huh?
Center of mass. Like why is the Earth going around the sun? Because there are two bodies, right? One goes around the other. So why is the other one go around the bigger one why can't the bigger one go around the smaller one? So basically, if you consider two masses of same mass, let's say two bodies of same mass.
Okay. I thought when you said center of Mars, I thought you meant Mars, the planet.
No, MAS is mass. Yeah, the total mass. You have two objects of the same mass. Okay.
Yeah.
Now, where will they go around? So there is a center of mass, and one will go around that center of mass. This also will go around the center of mass. So it will go around like this.
Okay, and because the difference in the mass of the Earth and the Sun is so big, the center of mass is much closer to the Sun.
Yeah, closer to the Sun, but not at the center of the Sun.
Where is it? Somewhere on the edge of
inside the Sun.
Inside the Sun.
Yeah. So actually, the Sun will go around that center of mass.
Got it. Understood.
Yeah. So the Sun is actually going around the center of mass.
Wow.
That's a very small wobble, right? You can imagine a small kind of a jitter. It will have small wobble.
Right.
This is the wobble the telescopes have picked up of other stars.
Understood.
It's a very small wobble.
Wow.
So you have to detect this extremely small wobble. And like I said, why is this wobble happening to this star? Why is this star just doing this? It's because of some unseen thing going around it.
Okay. I understood exactly what you're saying, but let me just repeat it once for the viewers.
Sure.
Okay. So basically, according to the laws of gravitation, if there are two massive bodies, a planet and a star, you draw a line between the two. You take the mass of each of those. Now, obviously the star will have a much larger mass.
Yes.
Therefore, it will pull the center of mass towards itself.
Yes.
And both those bodies will rotate around that center of mass.
Exactly.
Now, the planet is quite far away from that star. So, its radius of rotation will be much larger than that star, which will actually have the center of mass within its own body because it's so heavy as a object. So, it has a slight vibration around that center of mass, which is inside its own body.
Correct.
Now, you're saying that when you look at other solar systems and other stars,
Other star.
you're able to pick up that small vibration.
Yeah. Some wobble. Yeah.
Yeah, because of which you're able to understand, oh, it's got an interference from other planets around it, possibly.
Yes.
Then you'll look for the other planets.
Exactly.
That's
That's
how.
one of the ways of looking at.
Okay.
Yeah.
Okay.
So this is important, and so this what I'm saying is, as the astronomy right now is extremely precision based. So this precision is what is telling us not only the detection but also estimation of what kind of planets it can have is one of the ways of detecting planets.
Okay.
So this we can go quite deep, like small signatures differences you can do, and even with that. We have not detected the 10. I'm saying that I just wanted to bring it out because it's not to do with the detection way in which you have to find out we know asteroids which move around. So planets would mean that they are not like the stars moving. They have a different type of orbits, but they have to be very faint. You have to pick it up.
Okay.
So that is why we are not able to detect anything beyond Pluto, even if it is there. Like the evade. Yeah, the one which is evading, right? If it is there kind of a thing. But we are detecting in terms of gravitation. So
You're saying there's a limitation of our current mathematical methods and our current technology.
Yeah, it could still be. Yeah, the technology could still be improved to figure out how to do that. But the technology is actually pushing the limit of things, because even the other method of detecting exoplanets is like. The planet is a very small body, and when the planet, let's say I don't know whether people have watched the transit of Venus. Venus goes in front of it's like a eclipse part, but then the Venus will go in front of the sun and move very, very slowly. Okay, so that transit will be a small dot which will be move in front of the sun like that. So when the dot moves along, the total brightness of the sun will be reduced by about 0.1% or 0.01%, very, very tiny bit. But we are able to detect such variations in other systems. So that's a high precision, you have to be very carefully estimating those measurements. So then that is how we are able to estimate it. So it is not possible to even technology is advanced to the extent that we can actually measure these little deviations.
Wow.
Though they existed before, we were not able to measure. So the technology is the key here.
Got it. I still find it so weird that we figured out how to kind of map out distant star systems, but whatever is near our own sun, we're not able to. It's a strange reality of science.
Yes, that's right. Yes.
Okay. What do you find very weird about our own solar system? Like, what is very strange for you as a scientist?
I mean, I don't know whether it is strange or not, but see, we cannot say that is a strange as of now, because that is our
reality.
Not only a reality, but that is our a model, comparison model. We have only one, which we know it very well. So we use this. Okay, this is what we have now. What is that? What is out there? What is out there? So we don't have so much of details to say that this is wrong and that's correct, or this is theoretically possible and that is something is wrong with our solar system. So we still do not have that much of information.
Can I ask you a science fiction-y question?
Yes, sure.
So we have the periodic table in chemistry.
Yes.
We look at it with a viewpoint of it being complete, but could more elements be added?
Yeah. Actually, if you look at this periodic table, the elements are made in the stars. All the elements are made in the stars. The elements which are being added up are human-made elements, but they are all very unstable. They're all quite massive, radioactive. They're very unstable elements.
Okay.
So they will live only for a very short period, and then they decay into more stable nuclei.
So there's no chance that we'll find a new...
Even if we find, it's all probably for academic purposes. We can't use it for anything as such.
Okay. Okay. All right.
But there would be in nuclear fusion experiments, there would be for short lifetime, there would be some coming, but then immediately they decay down to stable nuclei quite fast. Yeah.
Okay. I'm sorry we're deep diving so much into science.
No problem. Yes.
How are you liking this conversation?
Yeah, very interesting, very diverse, because we are going from biology to, chemistry to physics and mathematics. It's very nice because that's the way we see things around, and we need to put them together in kind of a framework. Yes.
No, I'm glad, ma'am. I'm glad Indian scientists are now being celebrated on the internet. That's one of my main goals with TRS. But I've got to create episodes based on what the audiences demand.
Yeah.
And I feel now people are ready for scientific
That's
conversation.
Right. Yes.
For years, people didn't want even knowledgeable conversation. Now people like podcasts. And within podcasts, they're liking these deep dives into chemistry, physics, biology, etc.
Yeah. Very nice, yes.
I want to ask you, what's the most fun part of your job as an astrophysicist?
Scientists generally will say that, you find what is the thrill you get by doing it. The thrill is that sometime you will find that you will be the first person to know that something about something. Nobody else in the world would know that.
About some star you see.
Some phenomena or some basic physics stuff. Oh my God, this actually works, or, this actually exists. I thought it might, but then it actually exists and I have the proof with me. So that kind of a thrill is amazing, yeah.
Is there a part of you that has a small fear in your heart that one day you'll be looking into your massive telescope and you'll find like a meteor that's heading towards the Earth? Have you ever thought of this possibility?
Yeah, so meteorites, the small particles do come, but then the asteroids which come and kind of a strike kind of a thing. But with the bigger telescopes, of course, that could have happened long back. But right now, with the kind of mapping we have of the sky, we will know its orbit very well ahead.
How much ahead?
To the extent that I think we will know it in a few years ahead. Of that, because we know we can trace its orbits. So right now, previously people used to think that, I have taken the picture of this part of the sky. Why should I keep going back to that part of the sky to take pictures? The sky is it's the same.
Stable.
Yeah, stable, the same. So there's no variation in the sky. But now it is not so. The massive stars erupt. They call supernovae. And that eruption happens in most of the galaxies everywhere. Previously, about in 1980s or mid-80s, 90s, you would get about a handful of them. You could detect a handful of them per year kind of a thing. Now, there are like thousands of them because you know that they're going off and you need to study them. So because you're going back and having these surveys to look at them, you not only see them, but a lot of other things. These asteroids will move faster, so you can... our telescope in Himalayas, we have a small one, but even that detects a lot of asteroids. So
the reason I'm bringing up asteroids, especially for the audiences, is because I don't think people understand how dangerous massive asteroids can be for the Earth.
Yes.
It's the equivalent of a human being shot with a bullet. That's the kind of speed asteroids hit you with. So even an asteroid the size of, say, a city could actually create a lot of apocalyptic events on Earth. And there are asteroids which are as big as cities out there.
Yes.
The speed with which they can hit the Earth can create effects on the other side of the Earth as well. That's how impactful an asteroid impact can be. And that's what destroyed the dinosaurs.
Yes.
There are theories about something called the Younger Dryas impact theory, which I've spoken about a lot on the show. Are you familiar with this?
Yeah.
Around 11,000, 12,000 BC, apparently a massive asteroid had hit the Earth, which has given rise to all these stories of Noah's Ark and Gilgamesh. And even in India, we have Manu's story that massive floods took over the Earth.
Yeah.
So this is a possibility for the human race living on Earth, that we can be hit with an asteroid, which is why I want to ask you as a scientist that, say we're able to detect an asteroid which is going to hit the Earth. The protocol will be to nuke it, like to send an atom bomb and destroy it before it hits the Earth?
Yeah, so there was a mission recently called a DART mission by NASA. So DART mission actually was targeted to an asteroid, and then they actually crashed the spacecraft onto the DART. Onto the asteroid
Okay.
to see how much they can deviate its orbit path. So they could actually successfully crash it and then deviate its path.
It actually moved away.
It's deviated its path. How much I am not able to remember, but this is a serious mission. Not nuke it, but change its orbit so that it doesn't come and do it. So this is already tested. Yeah.
Okay. If we actually throw a nuclear bomb onto one of the asteroids out there, what will happen? It'll just get destroyed fully? Like it'll vaporize?
So you will create a lot of debris, and then you'll have to figure out how these debris take care of all this debris.
But if it's actually debris, like say that city-sized asteroid that you're destroying with an atom bomb, you're creating much smaller asteroids from it.
Yes.
Now those smaller asteroids will melt away in the Earth's atmosphere, right?
When they enter, they should melt away. But then when you are actually navigating, they will all cause problems.
Like what?
When your spacecraft is navigating, and if you do not know things, they can come and crash onto the experiment or spacecraft or your, the solar panels.
Okay.
So they can actually destroy it. So right now, you know the asteroid or the bigger sized objects out there, and then you need to avoid them when you do a deep space voyages and all that. But if you create certain plumes around it, even a small particles can damage the spacecraft.
Okay.
Yeah. So we are actually dealing with a lot of space debris in and around Earth, but this can cause a lot of debris beyond space.
What is space debris?
Space debris is like unused satellites which still orbiting around.
They're all the dead bodies.
Dead instruments which are still orbiting. We have lost control. We have lost communication with it, but still out there. And that is, we do not know its position, what exactly it is. So it can. There are many times where our own ISRO spacecrafts have to be changed its height, etc., to avoid collision. Anti-collision maneuvers. Yeah.
Okay. Wow.
So that's a big menace now.
And what's the solution?
The solution is first one is to identify what is existing there and do a cleanup if possible, or at least know where they are. And second, don't create more. So the newer missions, there has to be much more guidelines, etc., regarding how you actually decommission a used spacecraft. So the low Earth orbit, if you look at about 300 kilometers or something like that, they actually deorbit and burn in the atmosphere. But the higher ones you go, it is still left there.
And causing problems.
And there are now worldwide networks of telescopes and detection mechanisms where you can actually detect these smaller pieces, get their orbit, and predict where they can be.
But I'm sure this will cost money. And maybe the world's governments are not ready to spend money on a problem that's up there. I'm assuming that that's the issue.
No, actually it is becoming more because we are getting some satellites damaged. And you can't afford to do that.
Okay.
So even in India also there are efforts. Then there are specific telescopes being set up to monitor the space debris. And not only monitor, actually there are even startups and companies trying to model it and sell that this is the data. We have the data, but we can actually give you the model and coordinates of the space debris.
Okay.
So this is a interesting area.
I want to know a little bit about this whole space tech startup conversation. You hear a lot of entrepreneurs throwing around that word. India has a lot of space tech startups.
Yes.
What are they building?
They're building multiple things. Some are building cameras which can look down on the Earth and Earth observation and things like that. There are also startups building communication, because still, if you want to have a spacecraft up there, you need to communicate with it. So you need to have communication mechanisms from the ground to the spacecraft.
So is the customer like just ISRO and the Indian government and other governments of the world and other space agencies?
Right now, all these areas have been under government. Okay, starting from building a rocket sending a rocket, communicating with it, operating it, and getting all the data from it. Everything was government based. Now you need to have all these individual items I listed out have to be built in the industry as well. Because if you want to have multiple number of missions more, and then you have to have communication networks more, then only one agency cannot do it. There's a lot of opportunity there. You need to have multiple set of people looking into it. Even if you look at this Chandrayaan and Aditya L1 mission, the communication with the spacecraft when it was orbiting and changing the orbits, etc., had to be, you have to network with NASA and ESA and, antennas. These communication are very safe communications and with certain bandwidth allocated for that. But these communication networks are also people are trying to understand and how to build it. And of course, the rocket propulsion with even electric propulsion is being tried out. So various other things and all these sectors are tried out.
As in, there's a lot of scope to help your country's space agency and your country's government explore space further.
Exactly. Okay. There are certain areas where you need to have many more of them and also innovate in a different way, build in a different way.
Okay.
Yeah.
Can anyone get into a space tech space?
It is very highly fascinating, but it is also a lot of hard work and a lot of iterations, because the way we succeeded in landing on the moon, it is not a joke, and you need to be very ready to face failures and learn from it and move forward. And many of these experiments are very long drawn, and every time you have to have critical evaluation, and if it is not performing up to the mark, even 0.1 or 0.01%, you have to say no, there is a problem, step back, correct it, and then only move. So it's quite painful, painstaking, and long drawn.
It's very R&D based, very product focused, and the money you'll make will only be in the end after your project is complete.
Yes, but then there are a lot of other byproducts you can get, because the technology you're developing and then the techniques you're developing can be applied to very many areas.
Okay.
So those things are possible, definitely possible, but it's a lot of deep tech.
Let's go back to astronomy.
Okay.
When I want to impress a group of people, and usually it's maybe some girls are also in that group, I will look up, and the only part of astronomy that I understand is Orion's belt, because it's so identifiable. The three stars are just like in one line. Right. Firstly, I find that very weird that 3 stars are in one line. Is that a weird thing? Have you ever looked at that and asked yourself, why is it in one line like that?
There's another three stars in one line inside Orion itself. No, Orion's dagger is 3 lines. So it's the pattern. You have a statistical way in which looking at it. I don't think it's weird, but
I don't know. I find it extremely strange how straight that line is.
Yeah, that's right. Yes.
I almost look at it from a bit of a spiritual bent.
Okay.
That why is it so straight as compared to all the other stars? So I actually got into some spiritual reading related to Orion's belt.
Okay.
And again, this is very conspiracy theory zone, but I'm just telling you because now we're having an open-ended conversation.
Yeah.
I found out that there's something called the Sirius star system.
Sirius is a star, yes.
Is that near Orion's belt or?
See, first of all, you should know, I'm just saying that these stars are projected in the sky. They're not at the same distance.
What?
They're not at the same distance. They can be at different distances.
Oh, you
all
mean?
All the 3 are not at the same distance, like 1, 2, 3. They could be one very far away. For you, it's all projected.
Got it. Yeah. As in the vision you see is all 3 of them in one line, but actually they're at very different depths.
Yeah.
Okay.
Yeah. And Sirius is another one, which is it's a binary system. They got 2 Sirius A and B. There are 2 stars. It's got
Okay. So in the spiritual conspiracy theories, I found out that it's something related to the alignment of the pyramids as well. Like the pyramids were made to point towards, I believe, the Sirius star system, and there is
in Orion,
a set of pyramids which was constructed to point at Orion's belt, to represent Orion's belt.
Yeah. So what I have understood with this Orion connection between Orion and the pyramids of Egypt is that the Nile floods in a particular season. So they wanted to figure out when this Orion rises in the east. That is when the Nile floods. So
Okay.
their calendar, and then the identifying there are some particular holes in that directly you can see at that position Orion coming up.
As in the pyramids, they've constructed
I
holes.
think so, yeah. That is the alignment in which. So there are a lot of other things like Stonehenges and a lot of objects are there, older systems. But here, this particular thing is to look at the flood. It is related to the flooding of the Nile.
Okay, wow.
Yeah.
So time travel, ma'am. Should we begin by talking about Interstellar? Have you watched Interstellar?
Yeah. I have watched Interstellar. Yes.
Did you like the film?
Yeah. It's a nice movie. Yes.
As an astrophysicist, why did you like Interstellar?
See, even for an astrophysicist, you need imagination to look at what exactly it would be, right, out there. So, I mean, you are a person, so you will have your own visualization of how things are out there, etc. So, when you look at things which are put out by somebody else with some context, with some storyline, of course, it's nice to see that. So, I think one of the pictures which I watched.
Okay.
Yeah.
All right. Is time travel something that comes up in your field of study at all? Do you all ever kind of ponder upon it? Do you all do mathematics around it? Because wormholes as a concept have come up a lot on the show, where I know that a lot of audience members probably at this point know what a wormhole is. For those of you who don't, think of space, like physical space or even outer space, as a sheet of paper. Now, if you draw 2 points at the 2 corners of the paper and draw a line that goes between those 2 points, that's the kind of distance it would take for you to get from Earth's star system to even like the nearest star system, which is light years away. But what if I take one corner and then take the other corner and then fold the paper? Now those 2 points are touching each other. You can actually do this with space. Theoretically speaking from the perspective of astrophysics, you can possibly do this. So mathematically, wormholes are a possibility, but practically they're not a possibility because the nature of a wormhole is such that when you pass through it, the wormhole collapses. Am I right? Am I wrong? It's a very raw understanding of what a wormhole is.
Yeah, I'm not not scientifically familiar with wormholes, but the point is that the theoretical predictions are many. Many things can be done. So cosmology, for that matter, was also theoretically various ways, how the universe would expand forever or collapse in one time or go, bouncing back and forth.
What is cosmology?
So, in the sense that if you look at the universe, whether the universe is constantly expanding and the nearby stars will ever, get separated over a time scale, or, they come back and collapse in the distance kinds of after a while it reduces or just moves back and forth kind of a thing. But now we know that we are expanding, and the future there was a big bang and then expansion takes place, etc. But these are all evidence based, so we rely on a lot of experiments and then do that. So but at the same time there are a lot of theories which you need to be ready for. If it is like this, then it should be the way it is. Universe is like this. Similarly, out there to explain various kind of cosmological features, you can put out various theories, but there are experiments which will say that okay, only within the framework only these theories are possibly correct, but these are not. We are not in any position to evaluate string theory, wormholes, etc. right now.
As in theoretically speaking, there's a lot of places mathematics takes you.
Yeah, exactly.
But practically speaking, engineering can't create those possibilities.
Yeah, right.
At least where we are for now.
Exactly. So you as you said, if you look at an analogy of paper folding, you have this paper and you cannot fold it on a large scale, right? So you have something has to be seriously happening to make it fold or whatever. So change the space-time environment right now you are in. So we understand space-time environment. For that matter, the gravitational waves, which were people used to be predicting, and we thought that we'll not be detecting them, but then now we are able to detect gravitational waves. So we know that there is a space-time fabric. They can get perturbed by these events, merger events. So we are able to detect them as well. So the technology is moving forward in understanding this fabric, but then we don't have any way of figuring out technologically how actually you can connect. But then there are time travel is, we don't talk in terms of the outcomes of such things, but then we talk in terms of development which can actually detect or do something, but at some times that outcome can come, but we're nowhere near to it at all.
How far are we?
I don't know, because 10 years ago when we said, okay, gravitational waves can we detect? Maybe we can detect, but we detected it. So we need probably, I don't know, some experiments have to be, I don't know. I'm completely lost at this point regarding that. Yeah.
This is what I appreciate about scientists. That scientists are very honest about where the limitations of science are at this point.
Yeah.
Theoretically speaking, could there be wormholes out there in outer space already? Because one of the theories is that, hey, could a black hole actually be a wormhole? Like if you actually go into a black hole, everyone knows that whole spaghettification thing, that you'll be killed by the black hole, basically. You'll be stretched and killed. That's what theoretically happens. But no one's actually tried to go inside a black hole. And that's where this whole interstellar climax also comes in play. Sorry, spoilers. Go watch the movie or stop this podcast right now and then come back after you've seen the movie. And for those of you who've watched the movie, 3, 2, 1, we're back. At the end of Interstellar, when he goes into that black hole, he's transported to another dimension. That's what I loved about that film, that it just kind of sparked off the imagination of science fans all over the world. That, hey, this is what could possibly happen. Maybe you're transported to another dimension. You don't actually die in a black hole. Have you ever thought of this? Have you ever thought of black holes being sort of wormholes? So I know another theory is that we see a black hole, maybe on the other side of a black hole is a white hole, which opens up to another universe or another dimension. What do you have to say, ma'am? I'm just like throwing out all the science fiction stuff I know and waiting for you to say, yeah, this is probably possible.
Yeah, so it's interesting. See, black hole has been fascinating topic for various reasons. Basically because it's a huge unknown out there, and the capability of physics and mathematics gets stretched. So what we as physicists and scientists are more worried about the framework of whether when you say something is actually valid, you need better framework to address that condition. So when we even get an outcome, we first suspect that it is an artifact of something which is not properly taken care.
As in the science has not been taken care of.
Yeah. So something, some factor you're missing out there, which is not really you have missed out. So scientists get into this framework of, whenever your result is, you have got a result, probably it is very exciting, but then first you have to make sure that that actually is valid physically and mathematically. Now, these are areas where they are all at the periphery.
Okay.
So one looks at that the result you've got is actually correct, and then you move on to something. So that itself takes quite a bit of time to understand. So there are millions of possibilities out there, what is possible or not. But in a movie, you can actually find the very nice way to project it, that this is one of the possible ways where you can bring it a person out of through the black hole out to the other side, kind of a thing. But then in reality, what the matter is there, what is the condition of the matter there? It's it's in plasma form, it's hot, whatever magnetic fields, everything is very complex there out there.
Okay.
And dynamics and the space-time curvature. So by the time you get all these parameters and solve it, is like a major mess.
Okay. Were you angry when you were watching Interstellar and the climax?
No, not angry. It's like it's for me, it's like a science fiction, but you have to kind of suppress your scientist evaluation. You just stop thinking in that light. Just look at it as a story and enjoy
it. We saw Interstellar as Nolan's best film. You saw it as a Govinda film.
No, not like that. But it's like a nice depiction of something which can be one of the million possibilities. Yes, I don't know. Yeah.
Just a possibility. Okay. What is the closest black hole to Earth? Or we don't know because you can't see it.
The black holes are of different types, like, stellar black holes, where, like, this is a serious case where you have a star and a white dwarf. White dwarf is basically the remnant of a star. But if the supernovae I was talking about, the big star which explodes, the remnant could be a black hole. Black hole is what physics means that the density is so high that the light cannot escape. You cannot see it. So you have to detect it in an indirect fashion. So you can be a star. There's a star which is going, just like the two mass thing which is going around we're talking about, right? The Earth and the sun kind of a thing. The same kind of a system, binary stars are there. Where the star which is going around the invisible black hole. Yeah. So that is how we estimate that there is a huge mass present in a small volume. That could be a black hole. But there are also centers of galaxies, like our own galactic center as huge black holes. Again, how do you estimate the mass of it? Again, the stars go around it. One has to figure out the speed with which it is going, find the orbit, and then using just normal gravitational laws, you can actually get the mass estimation of that. So these are all this two-body system which you talked about is actually relevant in many places.
So there are star systems out there where stars bigger than our sun are revolving around something.
Yes.
That's a possibility of the existence of a black hole.
The star which has been extremely massive collapsed, exploded, and the inner part collapsed, resulting in a black hole. But there would be some binary system where another star was going around it, which did not get disrupted in the process, but still continues to go around the system.
Okay.
And we measure the dynamics of it, and then that is how we say that, yes, there is a possibility of a black hole there.
Okay.
So such systems only in terms of binary we find, but not in terms of a singular black hole floating around kind of thing. Yes.
Okay. So are there scientists in the world who are dedicated to just studying black holes?
Yeah.
How do you study it? You see the movement of the star around it.
Yeah. So there are two ways. Mostly before the observations thing came about, black hole studies, a lot of theoretical studies, like, how a black hole can exist and what are the event horizon, the solving the physics equations and putting the magnetic fields, etc., etc. All the space-time curvature and all that. So the huge amount of people, large groups are there who study these black holes. In fact, I think just a couple of years ago, the Nobel Prize went in two sets of people. One is for the theoretical part of it. The other is for the experimental part of it. So both sides are equally strong. And the experimental part takes a lot of time because you need to actually measure the movements of the stars going around and painstakingly do it. So the Nobel Prize awarded to the experimental set of people was measurement taken over 20 years. Yeah. So if you look at towards the galactic center, towards our center of the galaxy, it's totally crowded. Too many stars out there. So you have to actually have something called adaptive optics, where high resolution. You need to figure out each and every star separate out and identify its motion. And it's a painstaking process. So astronomy historically is a very painstaking job because it takes a long time. You look at the planetary motions, you need years and years of data you have to collect.
Test cricket of science.
Exactly. Yeah, you're right.
Okay.
Yeah, so you have to be very patient with each and every ball in the test cricket. So you just hit it. So similarly, you need to actually patiently look at the observer, take the data today, tomorrow take the data. Next year-wise, then you actually compile everything. So this is 20 years of data which actually created the entire orbit around this central black hole of our galaxy and then estimate the mass. So black hole has been fascinating for quite some time for various reasons.
This whole thing that Elon Musk keeps saying about how eventually human civilization has to leave Earth and move on to other planets and become intergalactic and all that. Is that just a science fiction angle? Or do you also agree as an astrophysicist based on the climate change that we see on Earth today?
See, I don't know where we are heading to, but unless we have to have clear controls and things like that, because we are seeing the impact of climate change, a very drastic impact is going on right now. But leaving totally Earth, I'm not sure. But then definitely possibility of getting to other planets and making living possible there is definitely possible in the next maybe 20-30 years kind of a thing.
Ooh.
But after that, I do not know.
You say 20-30 years, and I've gotten to know you now, ma'am, and everything that you say with surety is with science as a base.
Yes.
So when you're saying 20-30 years,
It should be definitely possible because we are already in an International Space Station for such a long time. So we should be able to take, and with the moon mission, so many of the moon missions coming out now, technology rapidly advancing. It should be definitely possible to at least humans going to Mars, etc. But then colonizing that will take time, and then it'll depend on the expansion, or rather the mobility factor, and then how much we are able to spend money on it, etc. Because cost is a prohibitive factor. Yeah, but it's not. I mean, if you look at 5 years back, it's not the way in now, right? We have actually caught up with a lot of technology and things. We can actually do it. So it should be possible in a couple of decades.
You know, this whole space travel thing, like Jeff Bezos is starting a space travel company, Virgin Galactic, Elon Musk.
Correct.
It scares me. I don't know if I would want... I mean, I'd obviously want that experience of going to space, but it just scares me a little bit. Like, have you seen Gravity, the movie?
Yeah.
It's this one of the most uncomfortable, beautiful, but uncomfortable movies that I've ever seen in my life. And I highly recommend Gravity to everyone who's not seen it. It's about astronauts who get lost in space and how they figure out how to come back to it.
Yes.
It's the most uncomfortable movie you'll watch, and you'll feel like you're in space while you watch that movie. But anyway.
Yeah.
Like, does it scare you? Like, if
no,
you would go for a...
It is not very high, actually. It is not... I mean, the kind of distances you talk about, it is not very high. You actually go to about 80 kilometers, 100 kilometers thing, and then come back. International Space Station is 300 kilometers, 350 kilometers. So it's not much, and it should be doable. I mean, right now we have already seen multiple agencies doing it. So
would you go?
Yes, but you need to be fit enough and go through all these things to... I hope... I mean, if I get a chance, definitely I would go and come.
Why?
It's an experience to see the Earth from above, which you have not seen, and that's a completely different experience. So terrestrial, there are experiences like, the other experience will be to go down the ocean. That's also actually equally
like that
interesting.
Titanic submarine.
No, it's quite deep in there.
Titanic submarine style stories scare me away from like this whole Elon Musk space travel thing. Like, what if something goes wrong up there?
Yeah, that's right. No, the technology right now, like, air travel, earlier, just going by airplanes was not that safe, right? But now it's not that. You have too many, anybody can fly now. So it's not only about affordability, it's also about safety. Technology. And we have achieved it. So this should also be possible in a decade or so. It should be definitely possible, yeah.
When you're saying this whole thing about colonizing the moon, I'm assuming that the moon is the first stop that people are looking at for colonization.
Colonization, more than that, it's a resource center, not like a colonization. Colonization, probably Mars is a better place than gravity is there better, and then it's slightly better to land, easier to land in Mars than in Moon. Moon is a resource center, basically, not like a colony. Yeah, that's what I think. Yes.
Wow. Okay, because again, gravity, all that, it's too different from Earth.
It's the resources, yeah.
At the end of the day, we have a human body that we're limited by.
Yeah. So Mars is better for colonization than...
How do you begin to colonize Mars? I know Elon Musk on one Joe Rogan podcast, he said that you basically just heat up a planet. that's how terraforming is. Like when you're trying to establish a city, just heat up a planet. But it's difficult to heat up a whole planet.
Correct. So you have to do piece by piece.
That's the effect of science, right?
Yeah. So you need to have a heat up, as well as you need to have enough the required gases. So to start the whole thing, oxygen. Yeah.
So you'll have to figure a way to create oxygen, nitrogen, all that on that planet.
Yes.
But then why are you saying we're 20, 30 years away?
No. So this thing is that space, though the technology is ramping up quite fast, each mission time scale is a bit takes time, because once you have done it, you can probably go very first time. You need to make sure that everything is tested properly and you know the way you do it properly, and then once you execute it, now you can do it because you know what you've done correctly, so then you can replicate it faster. But then the first time it takes much longer. And safety, because when you're taking human beings, and the safety is of paramount importance there, so that conditions have to be met. So the first time it will take time, but then once you do, like, the kind of experiments, like why now we landed on the moon, but then we also try to hop. So you have to keep doing multiple things. Like, the Artemis series of missions which are going, they will do a huge number of experiments down the line, right? So then the humans actually going there will take place in a couple of years' time. So that's the moon. Back to the moon. Now Mars, so many rovers are there on the Mars surface already. So now you have actually known multiple things, and you have mapped the surface and understanding of where exactly what is the material and things like that. A lot of data has come already. So that will be the layer on which we are standing on that particular foundation and trying to figure out what can be done next.
Okay.
Yeah.
So it's a step-by-step procedure,
Step-by-step process, yes.
lot of experiments, getting data, getting the soil.
Getting understanding of what it is, what can be done, how it can be done, where it can be done. All these have to be answered first before you actually do it.
So there's no way you can visualize a colony of human beings right now. We don't know whether we'll live inside a dome on Mars or we'll actually terraform the full planet.
No, we'll have to do a little bit and test it out and figure out how to do that.
So
but
a
there are a
dome.
lot of ideas. Yeah.
A dome is
small
likely.
areas, likely to be smaller area to begin with. I do not know. I am also running my ideas.
Okay.
Imagination wild.
Okay. No,
Right.
that's what TRS is about, ma'am.
Right.
How do you get that bigger glass enclosure up in Mars?
It may not be glass. I do not know. So
It may not be glass.
Yeah. So we have to figure out an inflatable thing, and also, I mean, you have to take it out there, right? Carrying glass and putting it there.
Damn.
I do not know. So we'll have to have some amount of greenhouse effect to make sure that things grow inside. Yeah.
You know what scares me about inflatable? Some kid goes and just like stabs. And the whole thing collapses. Everyone dies on Mars.
No, I don't know. But we'll have to material which you can actually transport and then actually set it up there and things like that. I think we'll have to... there are a lot of material research also goes on. So we'll figure it out. What I'm saying is that the required technology, the required ideas, the required material, how you make that, they're all maturing. So as I said, if you want to do something, there are multiple things we need to mature simultaneously to actually achieve it, and that is actually maturing. So that is why I'm saying it is possible.
Okay. Dr. Subramaniam, this was great.
Thank you.
I hope you had fun.
A lot of fun, yeah.
Okay, that's it from all my science fiction questions today. Something tells me in my heart that this is not the last time we are meeting.
All right.
So please return on the show soon.
Definitely.
And I hope you had fun on
Yeah,
today's
I had
episode.
fun. Quite a bit of fun, yeah.
Okay.
Yeah.
I
Thank
will
you so much.
see you soon again in life. Thanks for the education. Very few guests leave me feeling so stimulated.
Okay.
So thank you so much, ma'am. I really
Thanks so
appreciate
much,
it.
yeah.
Awesome
Right.
having you.
Yeah.
Thank you.
Thank you.
That's it from our science special of TRS. These are the episodes I probably look forward to the most. I don't need to prep much for these because it's my subject. It's the closest subject to my heart. It's one of the close subjects amongst all these other TRS subjects that we have. Please give me your other recommendations when it comes to scientists. I'd like to know who else you'd like to see on TRS. It's the age of celebrating Indian science. It's the age of celebrating astrophysics. And TRS is going to be back soon with even more science-themed episodes.